Hi everybody. Today we're going to be working on the I can statement. I can compare rational numbers. And before we were just comparing two numbers. Today we're going to be comparing three numbers. So let's look at our first example. 0.45 repeating, 2 fifths, and 0.45. Okay, when we have these comparing problems, we really need to prove to ourselves that the numbers are bigger or smaller than the other numbers. Some kids want to just have a feeling about which one is bigger or smaller, or look at part of the number and not really reason it all the way through mathematically, and that's not okay. We need to make sure we have mathematical proof that which ones are bigger and smaller. So when I look at this, I'm going to start by comparing numbers that I think would be easier to compare. And I have two numbers that are already both decimals. So I'm going to go ahead and start by comparing those. I have 0.45 repeating. And I'm going to stack these on top of each other so that way I can compare them place by place. So 0.45 repeating, I'm actually going to write this out a bunch of digits. And then I'm going to line up my decimals and put 45 hundredths right underneath. And then I can fill in zeros so I can compare the whole number. All right, when I look at the first digit, they're the same. Second digit is the same. And then when I get to the third digit, you can see that the 0.45 repeating has a bigger digit in that place. So 0.45 repeating is bigger than 45 hundredths. So let's write those in order. We have 0.45 and 0.45 repeating. Okay, so those two are done. We need to look at 2 fifths and figure out now, does it go here, in the middle, or is it bigger than both of them? When I'm looking at 2 fifths, since I already have two decimals, I think probably my best option here would be to change that to a decimal and then compare them. Instead of changing everything to fractions, that seems like it would be more work. So when I look at my 2 fifths, I have a denominator of 5, and I know that that makes it easier to change a fraction into a decimal. So to get 2 fifths as a decimal, we'll do that down here, 2 fifths. 5 goes into 10, so I'm going to change this into tenths and then get it as a decimal, times 2 times 2. 2 times 2 is 4. 5 times 2 is 10. So this is 4 tenths, which is equal to 0.4. And I'm just going to go ahead and line that up under my other two that are already there. 0, I'll keep it in a different color so it's easier to see for you. 0.4, and then I can fill in zeros after. And I can look, first number is the same. And already at my second number, my second digit, I can see that my 4 tenths is smaller than the other two decimals. Okay, so this is the smallest number of the three. And I always go back to my original number when I put it in the order. So I'm going to put 2 fifths smaller than the other two. So 2 fifths is less than 45 hundredths, which is less than 0.45 repeating. Okay, let's do one other example. Excuse me. 3/8, negative 1 and 1/4, and negative 1 and 1/2. Okay, well, right away I see I have two negative numbers and one positive number. And I remember from our number line that positives are always bigger than negatives. So I know that 3/8 is the biggest of these three numbers. Okay, I'm going to put it furthest right, 3/8. Okay, so now really all we have to do is compare our other two numbers and see which one is the smallest and which one is the middle. So negative 1 1/4 and negative 1 1/2. If I didn't know anything about the fractions 1/4 and 1/2, I could get a common denominator and see which one of the two fractions is bigger. Since I know about 1/4 and 1/2, I'm just going to picture this on a number line, and I'm going to draw it out for you so you can see what I'm picturing in my head. I have 0, 1, 2, negative 1, negative 2. And I know the further this way we go, the smaller the number is. So negative 1 1/4 is going to be just 1 1/4 piece over here from negative 1. So this is negative 1 1/4. And then negative 1 1/2 is going to be halfway in between the negative 1 and the negative 2 right here. Negative 1 1/2. So that one is further left. Negative 1 1/2 is 1 1/2 is further left. So that one is going to be smaller than negative 1 1/4. I always picture negative numbers on a number line because it just makes it easier. It gets kind of confusing with those negative numbers because they're opposite of what we're used to working with, the positive numbers. So negative 1 1/2 is less than negative 1 1/4, which is less than 3/8. And look at all the work that I did to prove it, even though this one could kind of be reasoned in your head if you know enough about fractions. Okay, I hope that helped with comparing and ordering rational numbers.